All right, here's a root locus problem. It gets a little more interesting. We've got a complex root in the denominator. We've got a couple of complex poles. And so let's see what we can do with this. So we look at this. Our open loop transfer function has 3 poles and 1 0. So we're going to have one pole, three poles, 1 0. So we're going to have two of the branches going to infinity. So let's take a look at this and look at our S domain, and we've got a 0 here at minus 2, and we've got a 0 here at, a pole here at minus 3. So we've got a pole and a 0, and let me fix that. There we go. All right, so now we've got a couple more poles in here, complex poles. So let's see where they are using our quadratic equation, negative b plus or minus b squared minus 4ac all over 2a. And I've done the math before on this, and I can tell you, and I'll let you work this out, but this ends up being at negative 1 plus or minus 1j is where these poles are. And so we end up with a pole here and a pole here at minus 1 and plus or minus j. All right, so we can start looking at our root locus, doing our what's on the real axis with you pin up, pin down. We're going to start with their pin up at the origin, move along the negative real axis till we find a polar 0. We're going to set our pin down, going to move it until we find another polar 0, and then lift up. And so that's going to be our root locus on our real axis. And we know from our derivation that it's going to go from the open loop poles to the open loop 0. So our root of that branch is going to go from that pole at minus 3 to the 0 at minus 2. So now what do we do about these other two poles here at minus 1, minus 1j, and minus 1 plus 1j? Well, we know that we've got two branches going to infinity, and so we can draw the asymptotic lines in there, but where do the asymptotic lines go? Where do they intersect the real axis? Well, we're going to do the sum of the poles minus the sum of the zeros divided by the number of poles minus the number of zeros, and that will get us the intersection of the asymptotic lines and the real axis. So with the sum of the poles, let's see, sum of the poles, it's going to be minus 3 and plus minus 1 plus 1j plus minus 1 minus 1j. Okay, those are our two poles. And so that's going to be the sum of our poles minus the sum of our zeros, which is going to be a minus 2. And we've got 3 poles and 1 0 in here. Okay, so we look at this and we can see that this minus 1j and plus 1j cancel out, and so what we end up with then is minus 5 plus 2 all over 2, and so this ends up being minus 3 halves is where we intersect the real axis. Okay, so we can now draw our asymptotic lines because we know that somewhere like right in here is where the asymptotes cross the real axis, and we know 3 poles, 1 0, so we've got 2 poles going to infinity, so it's going to be plus or minus 0. So our asymptotes, our asymptotic line is going to be in here like this. Now, so what do we do from here? Well, we know that the root locus has to originate at these poles, okay, these open loop poles. So, and it has to go out to infinity. So the most natural thing to do would be to come along here like this, and come along here like this, and we can take those on out to infinity. And so that would be the root locus for this problem. So what is the interpretation of this? Well, we can see here at the low gain, it's going to be dominated, the low gain is going to be dominated by these poles here at minus 1, minus 1j and minus 1 plus 1j. And that's going to be dominated, so it's going to have a slight oscillation to it, and it's going to be fairly slow. We're going to get a little bit of a play in here by this pole here at minus 3. As we start cranking the gain up, these guys, the complex poles, are going to shoot out here towards infinity, and pretty soon they're going to become much larger than the pole here resulting that is between the minus 3 and minus 2. So at an increased gain, we're going to see this pole here that is between minus 3 and minus 2 become the dominant pole, and the other two poles are going to be considered high frequency and won't even play into it. And so as we turn the gain up, we're not going to get much increase in speed, but we're going to see that it is dominated by this pole there between minus 3 and minus 2. So it's going to be a first order issue. It's going to be a little distorted because of the 0 in there reshaping our step input. But we're going to see a first order-ish response that is independent of the high frequency stuff associated with these complex poles in there. So anyway, that's that problem.